I'm going to start the playlist on quantum chemistry with some weird things. One is I'm going to compare the atomic world to the macro world. For the atomic world, no surprise, it's chemistry. I'm going to talk about the hydrogen atom. Then I'm going to talk about the sun and the earth interaction. Why would I do that? Well, the sun and the earth interaction, if those are the only two things in space, can be calculated exactly. And the hydrogen atom with the proton and the electron can be calculated exactly. So that's important because the hydrogen atom is the only one we can calculate exactly. Now, here's another thing. I'm going to talk about adding the moon to the equation. Now, if we talk about the Earth, the moon, and the sun, and say those are the only things in space, that creates the classical three-body problem. And guess what? Even though we fly to the moon and do all kinds of calculations, we cannot calculate that entire thing exactly. We have to use approximations. Those approximations get very close. And when we go to the corollary, a helium atom, one nucleus of charge +2 and 2 electrons, that also is a three-body problem, and it requires approximations. So almost all of the virtually all of the calculations that we do to try to get to the nitrogenase problem, which, if you've forgotten, is what my goal is, to get at the cutting edge of the nitrogenase research where it can be applied to a quantum computer to eventually solve it using these approximations.